There are 5 main types of chemical reactions: synthesis, decomp, single displacement, double displacement, and combustion. A synthesis reaction is where two things become one. It's represented by the general formula A plus X gives you AX. Now these can be single elements joining together to be a compound, or two compounds joining together to become a larger compound. The opposite of a synthesis reaction is known as a decomposition, where a compound breaks apart into two or more pieces. It's represented by the general equation AX produces A plus X. Again, this could be an ionic compound or a molecular compound breaking into its elements, or a large compound breaking into two smaller compounds. A single displacement reaction is where one element steals another element in a compound. Some people like to use the analogy, it's a bodybuilder stealing a nerd's girlfriend. Here we have an element A is going to steal element B's partner. So I get AX being produced, and B has no partner to be with, so it becomes elemental again and gets kicked out on its own. In a double displacement reaction, two compounds react together and the metals switch partners. So a way to remember this is the first goes with the last and the third goes with the second. That way you'll get your elements lined up in the right order. The general formula for a double displacement reaction is AX plus BY produces AY plus BX. For combustion reactions, it's anything burned in oxygen produces stable oxides. Usually for combustion reactions we use hydrocarbons, so chemicals that are mainly consist of C's and H's. If I do a complete combustion reaction, that means that I'm only going to make carbon dioxide and water. If I do an incomplete combustion reaction, that's created if I don't supply the hydrocarbon with enough oxygen, I get more products. I'll make carbon dioxide, carbon monoxide, solid carbon, and water. You can recognize what type of combustion you have by looking at the color of the flame. Complete combustion flames are blue, and they burn clean. Incomplete combustion flames are either orange or yellow, and they burn dirty, meaning you can see smoke or soot coming out of them. Now that we've done some review, we can write balanced chemical equations for reactions if we just know the reactants. First, we change the names we're given into formulas. Copper, that's a Cu, and silver nitrate, that's an ionic compound because silver is a metal. So I have to use the crisscross method. Silver's got a 1 plus charge, and nitrate has a 1 minus charge, so I get AgNO3. This is going to be a single displacement reaction because I have a metal by itself and an ionic compound, so the copper is going to steal my nitrate. When I combine these two together, I have to re-crisscross this formula. Copper is a transition metal and can either be a 2 plus or a 1 plus. It's not told to us in the question which one to use. So we look on the periodic table and the most common charge copper has is listed first, and that's a 2 plus. So I have to cross that over my nitrate. Nitrate's got a 1 minus, so I get Cu bracket NO3 bracket 2. To finish off my equation, I add silver by itself. Now I need to balance. I have 1 copper on each side. I have 1 nitrate here, but I have 2 nitrates here. So that means I need a coefficient of 2 in front of my silver nitrate. That gives me 2 silvers on the left. I need a 2 here to balance my silvers on the right. You should also put in your states. Copper is a solid at room temperature. This silver nitrate is an ionic compound in a single displacement reaction, and it's on the left side of the arrow. It has to be AQ in order for this reaction to happen. Ionic compounds on the right side of the arrow, like copper nitrate, you have to look up on your solubility table. You'll notice that nitrate isn't on the table that I gave you. That means that it's always aqueous. And silver, it's a solid at room temperature. If you don't know the states of elements, then remember on the periodic table in our classroom and in the back of your textbook, there's a color code.